Итак, друзья, всем привет!
Коллеги, всем привет!
Hi everyone, and today we're going to tell you about the toolset in order to analyze the network. For that, let me introduce myself. My name is Ivan Dichkov. I'm a SOC team lead in Wilders, and my name is Ivan Savetki. I'm Raiffeisen Bank Russia Incident Response Service Analyst, and Ivan Tishchenko is our colleague there, who is working as the senior engineer for SOC, and although he is not there on that stage, but he did a lot to make sure that we are here to show you some very interesting things. Thank you so much. On the screen you can see three icons. Raise your hands, those who heard or worked with Suricata. Great. The icon below, that's a Moloch. Have you heard anything about that? Okay, lots of you. And to the layer in the upper left-hand side, this is not about the dog. This is not about Laika the dog. Okay. Chapeau. Let me tell you what NTA is about. NTA is a network traffic analysis, where this is also the full packet capture. This is a tool which allows to analyze the traffic, incoming traffic. In a nutshell, it not only analyzes that, that tool, but it would process that traffic, it would index that, put that into the database, and would exhibit that a convenient way, and you can see the pickup raw traffic, and NTA can do that. And why actually? This is needed in order to improve the visibility of the network, because although NetFlow is good, but it will never allow you to look at the raw unprocessed traffic. The second thing is that it can expand anomalous detection possibilities in our tool set. We have a tool which allows to analyze that following certain rules, and these mechanisms would be reported on a bit later. The network forensics and cybersecurity incident investigation. That's a very important thing in terms of the security, because the traffic, as a rule, would contain a lot of information, and investigate the incidences where doing the forensics that would bring about very important context. Misconfiguration detection. You might be absolutely confident that LDATS is working, but once you look at the NTA and you do not find LDAPs, that's the problem. And troubleshooting in performance and improvement, that's more an IT-related thing, but for instance, that should prompt you to work with the Network Operations Center, come to terms with them, and suggest that they have a single tool set. When NT is needed, this is when you have people who are going to look into that. It'd rather be a SOC analysis, but network security guy would also be optimal. Once you have some hardware which allows you to get that traffic, it might be done at the level of network hardware. For Cisco, for instance, that would be SPAN RSPAN. When you have NPB on Hegemon, that's the hardware which allows you to get the traffic and to resend that traffic somewhere else, and NPP, that's a network packet broker. In Russia, this is not very popular, but this is a very useful thing which may aggregate the traffic from different setups and could send it further on, for instance, to decipher that, decrypt that, or you can buy that. The point is that you have to know, or at least you may assume, what can be analyzed there. What element of the network should be most critical. Without that, it would be too costly to analyze the whole network, and hence you will have you will need a lot of capacity for NTA. A question: what would be needed most? The RAM memory, fast drives, or the drive capacity? IOPS and disks, yes. This is actually the drive space would be needed most. When I started NT and I worked with PT and AD, I was very much interested in what open source alternatives are there. 3 of them you can find on the screen. And I believe that PT and AD is the best one. Malcolm, ever heard about Malcolm? Raise your hands. 1 person heard about that. 2 people. Chapeau again. Malcolm has Archime under the hood, and there are a lot of things there. But we're not going to speak about that because I think that this is too much, and we opted for another way. What toolset we have? What is it about? Archime. This is the NTA function. Suricata, this is IDS mode. Strelka, that's for static file analysis, and Kibana and Elastic. So nothing special, no rocket science. Let's have a look at Archime. Archime provides for the full packet capture. That's about NTA. Out of the box, it enables you to make a distributed architecture and scaling. Parsing, that's very clear. So that's about the possibilities of NTA. Elastics, the same thing, and integration with Suricata, that's very important. Front-end and NetFlow. If hardware cannot actually give NetFlow, this is what Archime can do. Let's start with a capture node. This is a distributed architecture, so means that every element can use certain boxes. Let's start with the capturing boxes. That's a component that would get the mirror traffic, and this is where the whole magic is being done. Those who work with Suricate, what may go wrong there? Any ideas? 1, 2, 3. What can go wrong there? Well, the Suricate would get the files from the traffic, that's the smoker's way, and here we run into some problems, and then we opted for ZIG. How it all works? Well, the traffic comes to the traffic, and you'd rather use some optics for that, from Intel, for instance. Suricata and Archime capture nodes. Suricate would get files, would give us an opportunity for alert, and would record that on the file. And Suricata would make files and would get that to the front end, and Strelka will cover that a bit later. A few words about front end. Nothing special there. Front end and Archime and Kibana. And actually, you can find that right in the session, and the pickup would be offered immediately. Kibana is there in order to make flowcharts, in order to make dashboards, and have an opportunity for correlation, because front-end Archime cannot do that out of box. And correlation functionality is very important. Database, that's very simple. This is just a simple Elastic. It would get a lot of everything. The Strelka analysis, indexed analytics. It would get the correlation results, and Archime frontend would interact with it. By the way, not necessarily that would be one database. Let's speak more about Strelka. I'm glad that only 2 people heard anything about that. The main function there is about scanning Jara. All in all, Archime can do that out of box, but context is too little. Archime provides more context to analyze the files. The statistical analysis of files, that's very simple. For instance, you can get the window-based binary and you get metadata library. You can make hashes, and there would be about 10,000 lines in the log. Indexing data is then sent to Elastics. Then you have 30-something other scanners. And then the most interesting functionality is that Strelka can send the files to Sandbox. Actually, out-of-the-box functionalities that can send to the Cuckoo, but it can be done elsewhere. In terms of the architecture, there are two components, front-end and back-end. Backend and agent. Agent is being installed on the capture node. It would get the files, and we said that to the backend. Backend would analyze that and would send that information back to the capture node, and it would keep it there. Okay, another scheme there is, this is how it looks like, the big picture. Well, in essence, if the chat traffic flow is not so big, what you see there, actually it can be around two pieces of hardware, but the best practice is that when actually you have a distributed infrastructure to contain all that. Before I said, I already told you what should be done to the hardware, and storing traffic is too expensive. Ivan will tell you more about that. Yes, that's true, guys, and lots of people said that web resources are not for free, and this is about the engineers' work and analysts' work, etc., etc. Let's speak about the capacity in terms of the NTA. This is not rocket science, let's imagine. Actually, this is 33 gigabits. Not too much, not too little, but on the Archime website there is a calculator that will help you to find out how much hardware you need, depending on what you want. If we want to get 33 gigabit and the raw pickups to be stored for 14 days and the index traffic to be stored for 30 days, well, in essence, this is not too much at all. You will need approximately 3 petabytes of space for the big number of machines housed, and this is only for the pickup, for the capture nodes. As for elastics and other things that would require some more hosts, let me draw attention to the fact that you cannot just take one node and make it digest more than 5 gigabit, where it means that there has to be 7 capture nodes. So before you implement that, you have to think twice what you want, what is available to you, and will the deployment or installation cost be more than the benefits. You have to do that intelligently, smart way. So let's speak about other disadvantages apart from hardware. Actually, there are other disadvantages, and that's Suricata under the hood, and it means that it would have Suricata rules, and sometimes they may provide false data, and through Archime interface we cannot deal with Suricata Online. We cannot disable that, we cannot upgrade or modernize that, we cannot whitelist it, we cannot even have a look at that. If we want to do something, we go to the server, we do that, we restart Suricata, and here it is. Now good. Second thing also related to Suricata, as far as we have it under the hood, then there should be a signature. What signature we have, sir? There. So once we have open source solution, so the signature is also open source signature. A lot of false positive and false negative data, and there are things that were not updated for quite a while, but the non-open source ones are not for sale there. Let's speak about the files. As Ivan put that correctly, Surikata, out-of-box cannot extract files. It can do that, but by default this is 1 megabyte. If we make that any size, then if the files are more than 10 megabytes, the whole system would fail, would collapse, and you will install Zeek. We extract the files, we want to have a look at that. Can we do that through an interface? No, we cannot do that, well, unfortunately, at least as for now. Now, our toolset has several interfaces. The one of the Archimed itself and the interface of Kibana, where we look at the results of Strelka. If the node is not too big, then you can use Kibana. Then machine learning, that's a cool topic, and this is very frenzy, very fashionable, but this is not under the hood. If you want to do that a good way, actually you have to do that on your own. We have Elastic, we can develop it ourselves. Or if we obtain an enterprise license, as far as we have Elastic, we can do it this way. So this is not a drawback, but this is a fact, something you have to bear in mind. Then decrypting encrypted traffic, it cannot do it. On the other hand, it should not do it. Besides, there is another thing that would decrypt it, and here you go. There is one more thing I would like to tell. That's about the support as an open source product. Support should not be very good, but here the support is top-notch. They have a Slack channel and a weak response instantaneously. I've never seen any request that would be there for more than a day. Not all the vendors respond within a day, but this is the big question when actually you ask a question 10 minutes to 10 and 10:30 actually getting the answer. So 30 seconds, 30 minutes. That's a typical way to answer the question. So this guy helped us a lot, and besides the Slack analysis, would make a history of the request. So yeah, the question, you look for that, you search, and if you do not find that in FAQ, then you can ask that, and anyone's actually answered my question within 3 minutes. That's it. That's it. Let's have a look at the visuals, at the interface, and let's consider one case. This is our installation. This is how the front page looks like, and that's the session. And on one of the days at night there was some peak. That's very unusual. Let's have a look at that. What happened there? What Surikata signatures were recorded, and there were a lot of alarm triggered after a file was uploaded from my external IP address, and it was not a URL-based uploading. This is when we got a splash. I suggest that we focus on the file that was rendered. This is the result of Strelka analysis in Kibana. And one slide back, this is the time when the attack started. It is 13 past midnight, and 14 minutes past midnight. We already have a result of the Strelka analysis. Let's have a look at Jara signatures. We used elastics, and lots of Jara signatures out there. and these ones would be modern enough, and moreover, there are special signatures that would detect this file just the way it has to look. So let's analyze the signature. So let's start with the network signatures, Jar ones. As we see, there is a functionality to open a port and ID connection, a couple of other interesting things, interaction with the files and SOC library. And this all is packed in one file. So the conclusion is that it opens a listening port, it opens an outbound connection and interacts with files. It looks like a reverse shell or a pivoting tool. So any ideas what it can be? One binary has a functionality that you see on the slide. Do you have any ideas what this tool is about? No, this is not Netcat. Cheesy, that's an interesting version. Any other ideas? Let's look at pivoting. Okay, there are no ideas. No, this is not cheesy. That was a very cool idea, thank you. So there are two results, Cobalt Strike beacon or Silver beacon. I think that we could assume what it is. Now, since it was Sliver allows to do reverse shelling and pivoting at the same time. So let's analyze the traffic. Ivan will tell you what we saw in the traffic, and these results are quite crucial. Anyone would tell you why it was so easy to guess that it was Sliver. Really, we could make that conclusion quite easily, telling Cobalt from Sliver because it was a controlled hacking. What was there after the .exe file was uploaded? We saw that there were several attempts to upload that file, and then actually the hackers were not so skilled to do that at once, so they needed 4 attempts, and after the final installation, HTTPS connection was installed between the hacked server and the external server. That connection actually lasted until the very end of the incident. In Archimate, there is a grouping functionality. It looks very nice. We can install a filter what interests us, and we can see all the indexed fields and do some groupings. For instance, we have a filter with the source of the hacked server, and we add a filter to see all the destination IPs, all the protocols that were used. Okay. On all the signatures that's triggered, and we see the network Trojan detection, bad user privilege, discovery, NetWolf, and initial access. I like not suspicious traffic signature very much. Well, the free signatures sound like that. If you want a free signature, you actually are doomed to see names like that. Here we are, another functionality that I like very much. That's about hunting. Hunted, that's a retrospective analysis. Part of the traffic would be indexed, and part of the traffic that's a raw one. Roughly speaking, you can make a signature and retrospectively look when it is needed. When, for instance, when you saw some IOCs, and probably you actually ask a question whether other servers run into a similar problem. The same thing is being used to install a filter, and you actually select only events because it is very power consuming, but you can actually use the filter for everything. You have a lot of installations and a lot of hardware. Well, why not? Here I decided to look whether we had any base64 commands, encoded ones. And the system actually selected at the time interval, and there were 750 sessions out of 100,000 sessions where it used to be. So go forward and hunt, and then brings us back to this session and shows only the ones which are of our interest. As Ivan told you, we will show you that we now can see the raw traffic. As far as a lot of things are not visible under the hood, you may see the CyberChef. Raise your hands, those who know CyberChef. Other guys, if not, Google it. That's a very interesting utility. You can upload that, install it. You can do that online. Here it is under the hood, and hence it is even more interesting. But this very hunt, this assumption that there are some base 64 commands was not confirmed, so I analyzed the traffic and found nothing. In our little case, the signatures that were triggered were enough. Certainly, we'd like to have some good non-free signatures, that we have even more traffic, but in our case, that would be more than enough. So that's a very busy slide, but let me tell you in a nutshell what it is all about. We see that at night the file was uploaded. This is an initial access, then with some lateral movements, then discoveries, and pass exec took place. It's quite mundane, nothing special that I can tell you. Everything is quite mundane, so let's move forward. As far as we have Kibana under the hood, a lot of traffic has been indexed, and there are a lot of very interesting indexed fields, and you can dash many of them. I love Kibana. That's a very cool tool. Let me tell you in more detail about that visual thing. On the second on the right, there's a filter. If there were only two packages in this section, sync request and RST response. So let's count how many unique ports were there. So that's a kind of a scan. When we scan 100 ports, we send SYN and we get RST for all the ports, and here you are. And in that case, we see that from one IP address, there were lots of such requests to other IP addresses. And besides, we also see this splash there, and suddenly we can say that once you have a lot of traffic, we will not see the peak in one of two servers, but other filters might be used. That table is patterned to the interaction between two servers and summing up of the traffic between them. We see that there is a lot of traffic outbound from one working station late at night. That's very unusual, and a lot of signatures were triggered at the moment, although it was not supposed to be so, because it is late at night. Then the dashboard on the scanning, it can detect this low. Well, the events are not typical. That's a very rare case that one host would actually go to different ports. That's very suspicious. Then we added a filter, the hacked IP addresses, and looked at what happened to that. It interacted with the host, even though it was not supposed to interact. A lot of signatures sent an alarm, and also the scanning was done there. And it adds to one picture, and that was the case. That's quite illustrative to show what could be done with all that. Getting back to Arkeme. Arkeme has several very interesting features. For instance, having a look at the load on nodes, on Christmas tree, and Lots of vendors even cannot opt for the dark side. But now we told you about that in a nutshell, but in more details, you actually could listen to Ivan. We are limited on time and we cannot disclose more details in some cases, but we knew what this conference is about and we prepared an article. There are two articles published on Harbor. One was published a year ago, and we were speaking about that in every detail. And if you are missing certain technical details, if you want to develop something on your own, then the second article would be of help to you. Give me a second and we will proceed with Q&A session. So this concludes the main part of our presentation. And the most important slide before Q&A session is that we need people. And if you join us, you are most welcome. That's time for Q&A, and the first question was already asked from the first row. Can you pass the mic to the guy over there? Thank you so much for calling me a young guy. Can you use that in the production? Because there are billions of petabytes. Is it practically applicable in the context of a commercial company? Let me take that question. Yes, actually, it is in production, but it cannot cover the whole production. We took a little segment, but we made one installation, and that server is quite powerful. It has several terabytes memory, and it can. We actually cut the traffic, and besides, we didn't tell you that. We can isolate the traffic, and we actually can isolate the DNS traffic and encrypted traffic. We capture first packages, and the raw traffic is not being analyzed. So we have an installation 2 gigabit in peak hours. The critical segment will be digested very well, processed very well, and here we go. We scaled it up, we deployed it, and within a month's time we fine-tuned that, and since then it lives with no failure, so the pickups would be routed, Elastic will also be rotated, and signatures would go to the product CMs. And we are using that very well. Until today, we have not actually replicated it for the whole company, but it's being used as a pilot.
Да.
Повтори вопрос на микрофон.
Okay, we have a follow-up question. So we see a calculator at the website. Did we do it on our own? No, we didn't do it on our own. I mean the calculator, but we used it as a guide to plan procurement, and then we kind of hoped to have these things approved for procurement. So they made it. But we don't say that this is the only way to do it. Okay, there was another question from a guy. Yeah, this one.
Ребята, спасибо за доклад. Данил Смирнов.
Thank you, guys. I'm Danil Smirnov.
Интересует в первую очередь тема, вот, как это живет в инфраструктуре, мы поняли, что живет. Хотелось бы именно...
Okay, we understand that you have this in your infrastructure. Have you tried to profile in your company, in your infrastructure, some users or some apps? Try to integrate with Camber, with SODAP or anything else, so that some signatures should be shown, like a red team. You know that you have a red team. So when you have a pen test, where they check whether you are protected, so you can profile this, and you can see similar actions. Well, profiling red team is not right. Well, this is not right indeed. So if they crack you, you should see it somehow, not by looking through RCI IP. Well, Active Directory and some other things. Well, no, we don't have this implemented yet in the installation we have. So we have some local authentication, and for profiling, I can find this slide, I think. Issues. Yeah, talk about profiling. So if we talk about profiling as is, when we determine where the user goes and the IPs and ports they use, this can be done theoretically using the Kibana correlation engine. And if we talk about profiling as a white list, not that. Okay, I got you. Anything else I have missed? Okay, profiling users. So we can take names to a specified field. So Kibana engine can support this. Some workarounds, but it can be done. Okay, the next question, please. Okay, you have the mic. Good. Asif, Roman Jet. Have you tried Moloch? Acme is a part of Moloch. Have you tried Moloch? This is my first question. Well, Acme is a successor to Moloch, so yeah, for the SOC. Moloch for SOC. No, we haven't tried it. So this is the first question. And the second question. You see when the traffic is going through the bit, you can have a look with Suricata. When you have pickup, you cannot use Suricata to see it. It's only IB. How do you do it? Do you replay it? Well, we need Suricata for alerts. All the traffic give me a second. All the traffic is seen in the interface. You don't need Suricata to grab it. Okay, and if you just send pickup to the system, it will not check Suricata. It will parse it by protocol, but not check Suricata. Okay, I got it. You cannot send pickups for checks. Well, for this, we can use a PLive replay. Well, this is okay, but we don't know how to tag traffic. Well, it just was sent to the overall flow and was lost there. So the only thing which worked was to either install a micro version of this on one machine, which would only work to check pickups, or you add a virtual interface and you do the PLive replay and on the traffic. So where you grab it, and there you can do analytics. And one more thing, this is open source, so you can add the upload button for sending this pickup to Suricata. Yeah, with the replay. Okay, and the final question: how many signatures do you write yourself? That's a good question. Well, you know, writing Suricata rules well, and quite a little bit. Well, I think few people, few far between. Yeah, we are not there yet. So you're just looking at the IT ones, yeah, and the open positive ones. There is another one with his hand held for a long time. So the one in the first row will be the next one. Okay, let's start with this one. Okay, actually, what you do is like a pattern, but I have a different question. So if we talk about performance, we are primarily interested in the traffic. In the traffic to be recorded, so it will be equal. I mean, NAT is quite expensive, but NAT has the endless effort because they have some correlation rules and signatures, and it can be easier to maintain, as you said. So to develop the rules, we have to go to the list of Suricata. So why do you think that you need this system, this open source build system, apart from what you can control completely? Well, indeed, you need some work. Okay, the question is about comparing this to PTNet, right? Well, I mean, why? Why this one and not NAT? Yeah, why you build your own solution? Okay, at the very beginning, I said that technically NAT is the best. Yeah, the way I see it, NTI solution. Yeah, subjectively. Well, in NAT, you have huge expertise, and they have a lot of cybersec features, so you need to add to Akamai. And well, let's have a look at the first point and think about this $3 signs. Yeah, I know this 8 digit or 9 digit. Yeah, I'm not about pricing. Yeah, so you can ask both about this. Well, technically NAT is better because they have everything out of the box, and they have huge expertise under the hood. I mean, human expertise. Now we have another person. Hopefully I have answered your question. Hello everyone, thank you. So, in a segment, a node can be a NAT, and you can see that there is some suspicious traffic going from this node. So how can you understand which machine is compromised behind this NAT? Maybe you can have some tools for fingerprinting. Well, we'll see the things in the pickups behind the NAT. So we can see the IP from NAT. So if we are talking about the balancers, then it's good to add 4.4 fields, and then we'll be able to see the real source. Yeah, there are some tricks with NAT. So you can install the sensor before NAT, why not? And then you can also tag it. Other questions? Thank you. So this person is kind of jumping to get the mic. Thank you. Hello, Andrei Belkin from Raiffeisen Bank. Yeah, here was a t-shirt. Well, this project started a year ago. It was really interesting. You launched it together, and I have to live with it. Here is my question. You are in Wildberries now. Will you take Archimate with you? Yeah, I think we will. Yeah, we really want it. Yes, we will. Or you can give us some hardware. Okay, thank you. And I'm staying. Okay, you'll be with me, just in the same boat. Okay, let's ask some other questions. I don't remember who was first. I'm glad that you have so many questions. So it's not only about listening, so you have some important questions. This is really nice. Thank you guys, really interesting. Maybe not having all traffic, but metadata or expanded metadata. Maybe it can be easier in storage, and the detecting logic wouldn't suffer much. Well, metadata is stored in indexed traffic, and in HTTP packages there are many fields parsed, and this is metadata, and it is stored in this indexed way. So all the indexed data is stored in the Elastic, and the backup is stored on the host. So metadata is stored, and for longer, and the lifetime is different. elastic, so what we give to ILM, and pickups are ranked by loading, so they have different lifespan. And I think that this metadata can be kind of brought to a format CM could understand to store this for forensics. It can be convenient. I mean, the network part of it. And the final question: have you considered some alarms in terms of thresholds, some behavior analysis, or some manual, maybe not autonomous? So if the number of sins is more than sin X, okay, combining this with CM, well, we can do it, and we can build some correlation rules. In our installation, we have Elastic, we have Kibana there, and you can build any logic you want. Talking about indexed traffic, Archimate can also give you the net flow, and CM can get it. And the second, so the first part, so you can have no storage of pickups at all, and only store metadata. That's fine. Can we send this data anywhere else? Yes, sure. Can we add alerting to this? Yeah, why not? This is open source. Elastic, Kibana, you can use UR, you can use ERP, you can go all together. You can use alert, and we have a lot of things, and Bavania has something to add. Yes, indeed. We can store all this. Well, say CM is not running on Elastic. Let's assume this. And from Archimate, we have all the data stored in Elastic, so the data are stored there anyway, taken space and capacity, and we are given this again for CM. Our CM admins will kill us for this. Yeah, indeed. So we have double storage, and here I didn't show the shippers delivering this to Elastic. They can be any, it can be a file bit, it can be end game or vector or whatever. It's up to you. Just grab the files the way you like. I think you had another question. Yeah, you'll be the next one, please. Okay, somebody else. Let me ask the question. How did you get the traffic? Using the tab. Okay. How did you solve the doubling problem? Which one? The traffic doubling problem. Doubles of sessions. You didn't have one session. You had multiple, didn't you? Indeed. But not so many. Is it visible? Yes. In the traffic you have tags, like not complete sequence, doubling, cannot complete sequence. How many broken sessions did you have? Your solution, we haven't performed this analytics. You should have, because you should understand effectiveness, because NAT has some repeated sessions and it shows it. Well, the question is how this traffic is brought. If it is brought by Gigamon, this is considered to be best practice and the best way when there are not so many failed sessions. If you have Airspan or Valid or VMware mirrors, then you'll have some losses, doubles, and there'll be some traffic failures. This is not the Archimate issue, this is a common issue, and NAD also has issues. I mean, the format of data delivery. And I agree, indeed. One thing to mention, to do this analytics, which one is better, you should compare this face-to-face. Archimate and NAD have to, two wires and compare the things and the number of destroyed or broken sessions. Do you have any interfaces to see how many sessions are broken and so on? Yeah, we have Kibana. Kibana doesn't show this. Well, it indices the broken traffic out of sync segment. On retransmits, well, retransmits are indexed. Yeah, they are indexed in the traffic. I think so. You can filter in Kibana. No, they don't show retransmits. Sorry. Indeed, we have discussed this with the Network Operations Center colleagues. They wanted the return splits we couldn't share with them. This wasn't really nice, but that's the way it is. Okay, do you have a year worth of elastic base? Yeah, you have the installation for 1 year. Has Elastic accumulated this metadata for a year? Yeah, I don't think Elastic can survive this. Well, indeed. LM for the product Elastic, and it is rotated on the Elastic chewing our traffic. It is rotated every 5 days. So Elastic is there for 5 days, the metadata. Yeah, we have some capacity, but not so much. So it sounded like Elastic can have as many indices as you want, but I have never seen this in practice. Well, sure. Yeah, storing everything and as long as possible is good. Well, we don't think that we'll have indexed traffic stored for more than 30 days. If you have pickups for 14 days, this would be a miracle. Okay, thank you. We had a question from the first row. Quite straightforward. So we know that the project is there for a year. Here is my question. How many people took part in all this, to make all this? And how much time was taken? Can you do this? Well, this is quite straightforward. Can you do it in a company which is not like Raiffeisen but smaller? Well, how many people do I need for this? 3. So these are those who deal with Alchemy. We have also network people who provide traffic, and we also have people who install servers, order them, and so on. So, how many people can do this? So we can do it if you have 2 or 3 people. And when we did it for the first time, we did it, well, the 3 of us. Well, the first time there were 2 of us. Then Ivan joined us. And the smaller the team, the smaller the installation, the easier it is likely to be. And we have a Russian community. Humber has some articles, well, 2 good ones. We have someone, you can find the Telegram links to me and to him, to Humber and Ivan too. So you're not the first person to do it. You have a community, you have people to ask questions, you have those who are ready to share experience. So I think that for a small company, this was not a big deal. Okay, let me clarify. In 0911 we had a guide from Citymobile. They had a cool story for open source logging, and when I asked this question, they said you need a year and about 7 people. So they sent everything to ClearHouse from Elastic. They have a good article and they do it in a very cool way. Okay, another question? Hello, thank you. Thank you. My question, number 1, the Suricata rules. So if you have a huge installation and you will have to update rules for every receiving agent. Yeah, this is a funny thing coming from open source. But you have CI/CD, you have automation, and so on. So you take GitLab, there you have the rules, and then Git push, then you go through the Ansible, and here is how it works. And the second thing on JSON. So Suricata has the JSON file, and then you read it. Is it a bottleneck? Because there can be some delays between the original time and the introduction time. Well, Ivan, could you talk about the process overall? How from FJSON you have the Alchemy line, where you have the package pickup, indexed traffic, and the signature. Could you talk about this process, please? Okay, I will talk about this and then I'll answer your question. Well, in Alchemy, well, we have a Suricata connected module. Look into the file. So if Suricata freezes the disk recording process or the plugin can freeze, but this hasn't happened yet. Well, but this can cause losses if it happens. So any issues related to Suricata are alert-related issues. And this is indeed a bottleneck. It is there. But we don't sell this solution. We just tell you that there are some cons here and they can be mitigated. Like the problem with the files was solved by Zik. I think we had another question. Yeah, I have answered your question, but you haven't tested whether you have any delays if you have a lot of traffic coming. No, we don't have benchmarks. Okay, thank you. Okay, another question. Thank you very much for the lecture. It's not exactly a question, but rather a recommendation. For the small companies who need to capture traffic, you have Snottle log, that is Suricata, plus Apache, plus Pepboard, and we have a full-fledged open source analog called Security Onion. Have you heard about it? Sure. Sure, we were inspired by them and we took their file grabbing rules. It's a bit simpler. Now it's integrated in Kubernetes. It's trendy and fashionable, and you can also send this. Well, I have traffic of up to 5 gigabits per second, and the hardware works there a lot. You have 64 cores. Okay, why are we not talking about Security Onion and Malcolm? Because there you're talking about packs, preset packs, but here we connected to the Alchemy modules we needed, and we went into the process of setting this up. Unlike the out-of-box way, you just install it and it works, and you can install and you can feed traffic there. Another one on the Suricata rules. Documents are quite clear. It's not that difficult to code. I coded 16 rules for my organization. Yes, I did scan this slide. Okay, good. Not the one to the harbor. Okay. Yeah, you should understand regex. Yeah, indeed. I know the people who write a lot of Suricata rules, and they do it well. And well, I listened to a PhD speech, and I just put down 10 rules, but well, we have experts like that. So I know people like that. So those who write Suricata, good Suricata rules, they are few and far between, and this is an issue because open source rules, well, we should improve it. It is a bypass contest showing the quality of the rules. Okay, thank you. Any other questions, please? Okay, we have one more. A brief question. The commercial products you have, NAD. Do you have any other NTA solutions? You haven't mentioned them because you don't consider them NTA. Well, I've dealt with Garden Monitor for quite some time, and well, do you really need it? I say. But are you from Garden? No, I'm not from Garden. What's your subjective opinion? The best NTA? Well, I'd like to take a rain check. Okay, thank you. Another question. You said that you'll leave Suricata and start using Zik. This is a different tool. I beg your pardon. We will go away from Suricata in terms of grabbing files. Suricata will stay there. It will analyze the traffic for signatures. And closer to have Zik grabbing files, exactly files, and sending them to Strelka. Okay, this is for files only. Indeed. Zika has quite good metadata features. They have tables and logs. So are you going to use it? So capture is enough for us. Okay, we really need people. Please scan this one. Those who write suricata rules, call us. Okay, thank you for coming. This is the final speech on a Saturday at 5 p.m. Thank you very much. Good job. I have people who came here from other cities to listen to me. I'd like to thank you. Yeah, thank you very much for your questions.